Welcome back, NPTEL students, for the week 3. I hope you enjoyed the content that we created for week 1 and week 2. I hope you're also getting some insights on the topics outside the topics that we're covering in the class, because this topic is very, very engaging and you must be able to see some of these topics outside the class also. Must be able to relate to some of these topics outside the class also. So I asked you to do an activity last week. Thanks for doing the activity, and thanks for actually sharing some of the comments on the mailing list. I encourage you to continuously do these activities, look at these videos. They're not really very difficult to look at, and they're not very long also. So, and many of them are public, open, so you should be able to actually watch it and then make some comments about it in the mailing list. Please consider doing it, and please come up with some interesting thoughts as you see these videos also. So what we'll cover this week is actually going over some ideas called privacy enhancing technologies, privacy invasive technologies, and then look at some social media privacy as well. Right? Privacy enhancing technologies, by the name by itself, you can understand that this is technologies that will enable balance between privacy and utility, right? So we've been talking about privacy until now. What is privacy? All that. Utility is functions that is available. For example, if you have a Swiggy, the functionality or the utility that it is providing you is to go order food, right? So that's the utility. So how to balance between this act of ordering food and having privacy also is what the privacy enhancing technologies is all about, and keeping the privacy policy discussions earlier on Facebooks and Twitter, balancing the act of I want to say what I wanted to connect to people around the world, I want to share information to the world, but still I want to actually protect my privacy, right? That balancing act is what privacy enhancing technologies would be. So this is more like also called as PETs. Privacy enhancing technologies. Minimize, so the goal for these technologies are minimize personal data use wherever possible. Can the use of personal data be minimized, maximize data security, and empower users, right? At the end of the day, we want to make sure that users have a great experience using the tool and they get what they want. Using the functionalities and using the tools that is being built. To express, protect the privacy of entities. Particularly, I wanted to refer back to this PII, personally identifiable information, which is what you want to protect using these technologies. Increase control, which is connected to empower users. Choose degree of anonymization, right? So you also want to make sure that there are ways by which users actually can anonymize themselves. Meaning, go back to the week 1, we talked about Weston's categorization of users, categorization, taxonomy of privacy by Daniel Soloway, all that. If you keep that in mind, you want to give users a continuum also to set their anonymization, right? Somebody wants to keep no anonymization to full anonymization, right? That was choose degree of anonymization. Now let's look at provide informed consent, right? We have already seen what consent is for the users to actually sign up, opt in for some information, opt in for some functionality, features, all that. Informed consent, right? Users should be aware of all the information for which they are consenting into, right? So they should be able to make a very informed decision on what they want. Data minimization, which is already mentioned, relevant to minimize personal data use, right? So that's what privacy enhancing technology is. Very broad characteristics of what a privacy enhancing technologies are, right? So now let's look at some examples of PET. First one, I think some of these you may have already used, you may be already aware of, but I'm just putting it in a context for this class. specifically saying that these are privacy enhancing technologies as examples. Communication anonymizers, voice over IP, so you must have used something like Skype, which fits this category, where the people who are speaking, it's actually hard to find out who are actually involved in a conversation if we just give you the conversation between two people. Right? Peer-to-peer networking. I'm sure you're using a lot of these things for downloading movies, interacting with people, chatting with people, all of that. These kind of networks provide you the facility of being anonymous. So shared bogus online accounts. Another, the list here is just some methods by which you can actually do anonymization. You can actually provide more privacy to the users. So here is one method that people also tend to use, which is create one email address, publish the username and password for everybody to use, and therefore in the process nobody will get to know who's actually using this email address and how it is being used. So the personal information that is part of this email address will be actually, because given that many people are using it, it's not possible to detect who the individual characteristics of the person who's actually using the email address, which is what it says. One account created, ID and password posted. ID and password posted online. Many people use, so one person identity cannot be actually retrieved. Obfuscation, by the word obfuscation meaning itself, just add some noise. By adding some noise in the data that you have, for example, while you're browsing, can you actually make the browser do some activity by which that the service that you're using thinks that there are activities that are not just you who's doing it, somebody else is actually doing that activity. Right, from your own browser itself, in addition to whatever websites you're accessing, can you add some noise that these websites also being accessed when you're not really accessing those websites, by which the service provider will think that you're accessing these websites and create a persona, personalization for you according to that, when it's not you who's actually doing it. So that's like adding noise here. That's the idea that I had written there, adding noise. Anonymization. We'll actually look at anonymization techniques later in the semester. Look at different techniques, how anonymization can be done. But for now, data can be, so example of healthcare provider, hospital sharing the data with a data analytics company, where the data analytics company can make some choices, analysis, results, and give it back to the hospital is a good example for anonymization. Data can be shared, individuals can't be found. If I am in the data set or not, it's impossible to find. That's the idea for actually anonymization. Pseudonymization, where I think the idea of Reddit, where you can actually use pseudonymous handles. Panurangam Kumaraguru can become Prof, CS Prof, and then nobody would know that it's actually PK there, which is using the handle, right? So that's the idea for pseudonymous. I'm sure you can come up with many examples. If you think of some examples where privacy enhancing tools that you use is there, please post it on mailing list. We can take it up and discuss it also. One very common and very important and influential technology that had come up for privacy enhancing technologies is actually Tor, which is built on this idea called onion routing. Onion routing, the idea is, think of it as just onion, right? When you start peeling onions, when you peel the outside layer, only the layer that is inside is visible to you, right? You get to see only one layer at a time, and that layer is just attached with the one layer that you peeled and the one layer that is below that, right? If I peel this layer off, it's attached to this layer and attached to this layer, right? A layer is getting peeled, B layer is this, and C layer is this. Just built on this idea that only two layers are attached to the layer in between, to the layer in that you're peeling, the layer that you're looking at in any way you can see it. That's the idea for onion routing. And Tor built on this onion routing method to provide anonymization. And the primary motivation for these kind of technologies are like journalists, right? Journalists want to sit in some part of the world and share some information to their headquarters, and nobody should know that they are the ones who are sharing it. Nobody should know the from where this information is coming, all that, right? So that's the kind of or the journalist wants to access some websites to write about it, and they don't want the trace of this particular journalist accesses website or the servers should be tracked. That's the idea for Onion Tor. Here is next 3 slides just shows you how Tor works, right? So the idea is step 1, Alice's Tor client. So some terms. Here is a Tor client which is installed at Alice's place. Let's take PK wants to access something, obtains a list of Tor nodes from a directory server, right? So I want to access some website. In that, my client, my Tor client, gets a list of Tor nodes. Tor nodes are these. Treat it as, let's take different servers that are connected on the Tor network. Gets the list of these Tor servers, my client, right? And then if these are other services that other people that I want to connect with, and here it says to node, unencrypted link and encrypted link. You'll see all these colors in the next slide also. Here it is the encrypted link between the users that want to interact with. I want to access some websites. That's the website that is being talked about here. Step 2, Alice's Tor client picks a random path. So that's why is this random will come clear for now. So if you look at this, these are the nodes, right? You want to keep that random because so that the traceability is not there. Which is, if Alice wants to go to another website later, that is not. You cannot trace back the path that Alice took because she's taking random paths every given time, and every user in the network will take random paths every given point in time. That's one advantage of the Tor. The Alice's Tor client picks a random path to destination server. Green links are encrypted. And red links are in the clear text. The last bit, which is jumping from the exit node, it's called, right? The exit node to the service that I want to access is this one. And where is the onion routing coming into picture? This server, right? This node, so to say, knows only the information that, look, it has to be sent to Bob and it is coming from, let's take a server A. Same way as this node knows only that it is coming from here and it has to go here. So let's take this was B and this was C, right? That's the reason why it is based on onion routing, and that's what gives it the power of getting anonymity while accessing these services. Step 3, if at a later time the user visits another website, Alice's Tor client selects a second random path. Again, green links are encrypted and red links are in the clear, right? It wants to go to another site, which is this again here. It takes a different path, so it is taking a different path, right? Which was not the path that was taken first time, and therefore the anonymity is provided, right? And again, onion routing method still follows in this image also. Hope that helps you to get a sense of what a Tor is. This is come up with actually Tor has a browser also now. You can actually go download the Tor browser and use it. Again, the way Tor browser works is the way I explained before, and you get anonymity to the services that you go access. You don't get, nobody gets to know who you access these services, right? I'm sure you would understand now. Tor, again, there are many attempts to also show how Tor can be broken. There's a very active research area which is to look at methods by which you can provide more and more these kind of anonymity and how these anonymity can be broken. That's a very fertile research area if you were to think about it. Next is privacy invasive technology. Given that we spoke what privacy enhancing technologies, I think it's very apt to discuss privacy invasive technologies are. I'm sure this list you can come up with a bigger list than what I've written it here. And then the basic idea is that it does not respect users' privacy. If you were to think about, if you were to go to this slide of where I defined what privacy enhancing technology is, and if you were not to do all of this, will become privacy invasive technologies, right? Spyware is one example. Share user details without users' knowledge. Spyware sitting on your machine, sending out information about your username, password, or your web history. Those information is shared to a third party, which is what a spyware does, and that's actually breaking. That's part of the privacy invasive technology. RFID tag has a lot of positive usage in terms of understanding my production line, in terms of knowing where the product is, all that, but it also has this negative effect of using the RFID tag, which is actually somebody can track the product. I buy the shirt and then I have a RFID attached to it. My some receiver can know if the RFID tag is still on the shirt that I'm wearing, right? Again, there are pros and cons. I think if you were to look at RFID by itself, you'll understand the more and more, meaning the receivers are not all around the world, right? The receivers are only at some point, some places, and also my RFID tag is not live always. For example, when you buy, I'm sure you've seen many of the shops where when you buy something, they remove a plastic piece from the cloth, right? Which is some kind of a tagging. You can think of it as some chip that is there, which is actually allowing, and you will also see a to device at the entrance or exit of these shops, which can also understand or pick up signals that whether any of the products that is being taken out has these tags in it. Right. Similarly, you can think that these tags can be kept, these receivers, so to say, can be kept anywhere, and then they can track us, right? If the RFID tag is not properly taken away when I bought the shirt. And the advantages of these technologies are very helpful. For example, cattle management, right? You want to know if I have like 1,000 cows that I have to manage, I think it's going to be extremely hard to keep a count on which all has come back to the back, and then it's going to be very hard to keep track of these cows, right? So therefore, they put the RFID tag, and then the receivers can keep track of who's and which cow is inside, and they get a sense of, okay, there's 6 missing now, we should go look for those 6. A Webbug, right? Another example. This is a very simple idea. This is more like a 1x1 pixel image that can be put on any website. Let's take you put on your own website this 1x1 transparent image, and then anybody who comes to your website your web page. This web page will make a request for this image, and therefore you know that somebody is accessing this website. Right. This image can be put on any web pages, and therefore tracking can be done using this 1x1 transparent image. So that's what it's called, Webbug, and it's also called as web beacons, clear GIFs, tracker GIFs, all of that. All of them mean the same thing, but the idea is this, that it is put on a website and then this image, so how the tracking happens, because this image is being requested, right? To serve this image on the page that the user is seeing, this image has to be served from a server, and that request is being made. That server can keep a track of this image being, this web page being visited by knowing that, oh, this image from this website was actually requested. And you can also think about this image being served by a common third party now, right? Multiple web pages can have one of these images from a company A, and this company A can track all the websites that users are actually going to. And company A can produce analytics to the companies and to the services, to the websites that people are accessing, and that can be very, very useful in terms of personalization and advertisements. So that would give, those are the list of privacy invasive technologies, and I'm sure, again, as I said before, you can have some examples in this list, and feel free to share the list that you have. So that was privacy invasive technologies. Now let's look at some techniques by which these privacy enhancing can be done, and tools that have been developed in the past which can provide more privacy to the users. Again, this is only a small sample. This is not comprehensive. We can go on this list if needed, but I'm giving you some sense of what are the tools that are available which can be used. So to make privacy information more usable to consumers, the decision making, right? Privacy decision making is this idea part of the privacy enhancing technologies itself to help users make choices of what all options that are available. Right? A platform for privacy preferences is one technique, one solution that has been developed where users can actually represent their privacy preferences, companies can represent their privacy preferences, and some matching can be done in these preferences and decision can be made. I'm going to walk you through what it is, but in short, that's what it does. User privacy expressed in this P3P format, company's privacy expressed in this P3P format. A machine can understand both of this now because it is expressed in a machine readable format, and this decision can be made whether this website is something I need to go or not go, should I be allowed or not allowed. XML format, and when you think about it, this comparison can be done in many different ways, right? Some different methods can be built. One of the technique that has been built is called Privacy Bird, but I'm sure you can think of many other interesting way to set this comparison, set this user and a company privacy policy comparison to be done. How does a general HTTP connection work? It works in a way that so first a website is making a request. This is W3C website. A request is being made. Web server looks at the request from PK's machine, and it actually serves the web page as P3P W3C website. It could be IIIT Hyderabad website also. How does a P3P work on top of this, right? P3P works like same website is being requested, IIIT.ac.in. Instead of actually the website being served, my web server first, IIIT's web server first only looks at it. It is the request is sent as request policy reference file. First, it is not asking for the website. It is saying that, look, somebody wants to access IIIT.ac.in. It gets the IIIT's website, and then it says, can you tell me where your privacy policy reference file is? And the web server says, okay, here is the location of my reference file, and then the browser is making the request for that particular P3P file, reference file, and the reference file is served. And now, depending on the output that you can, so the web browser knows the P3P policy. Now, then the HTTP request is made and the page is served. So this part we already saw. This part is what the HTTP request is, right? So that's how P3P works. Again, quickly, let me go through it again. Instead of just the web page being requested and web page being served, first the reference file is requested. What is a reference file? Reference file is the place where the HTML is kept. A P3P XML format file is kept. And when I know that location, then the browser makes a request for that particular P3P file. P3P file is served, and then now that P3P file has the preferences of the company, which you can think of it as all the privacy policy that we have seen until now. That format is converted into a P3P file. That P3P file is what is served back to the web page, right? And then the web page makes a request to the for the techologies.ac.in. So that's what how a P3P works. So as I said, P3P is an XML. So here is an example of what the P3P XML file could look like. And what all should it cover? It should cover the same things that we said, right? Which is everything in the privacy policy, the concern, data protection, security that is provided, all the Swiggy's and Amazon's policies that we saw can be expressed in this XML. So this shows a policy, what version of the P3P policy is, location of the human readable policy, right? So you should know that techologies.ac.in/privacy is where the privacy policy is. This is the access disclosure, human readable explanation, how data may be used, data recipients, which is who gets access to the data. So this is ours, this is admin who's getting access to the data, and then retention, data retention policy, how long the policy can be kept, data can be kept of the users indefinitely, it says here, right? Types of data collected, which is clickstream, HTTP, all the data. Right, it's talking about data being collected, who has access to the data, how long they can keep the data with them. Think of it as a privacy policy of any of the organizations that we have seen until now. All right, that's P3P. And now that the P3P policy is coming to a web browser, the browser can make a lot of decisions, right? As I said before, P3P is a way by which you can express the privacy policies in an XML format. Now that I have an XML format of IIIT Hyderabad's P3P policy, I can say whether PK is allowed to see that website or not, or is it aligned with PK's privacy preferences or not, which is what this Privacy Bird does. Privacy Bird looks at the privacy policy of IIIT.ac.in, it looks at my preferences, it makes a sound which is, if it is aligned, it makes a sound that it is okay in green, and if it doesn't, it makes it in red. Privacy Bird, and when it's, you can go look at why it is green and why it is red also, which is this matching, right? If the matching is, you say that, look, my preference is that I want to go to websites only which does not allow my information to a third party, right? Or which has retention policy as anything lesser than indefinitely, which is 90 days only they should keep the information, or which has an opt-in option, right? These kind of preferences you can set, right, easily. Again, you can set the preferences also using some tools. So this is providing you what the policy matching is, and here it is actually red color. It is showing where the where the matching is not there, right? Where it is actually different. So if you read this line, it says, unless you opt out, site may share financial information or information about you, which is the setting that I did not keep, right? As I said, I had said that it should be where opt-out option should be by default, the user should have opt-out option. Whereas here, opt-in option, whereas here it says, unless you opt out, site may be there. Site may be using that information or sharing that information. Right? Think of opt-in and opt-out again. Okay, so that was one method. So here is another technique that was built called Privacy Finder, which is based on search engine, where the input is search terms that people want to search, and the output is same as a Google search or a Yahoo search or search output that you can see Bing search. But in addition to the search results, it is annotated with the information of saying that, look, the privacy policies comparison that we did, this is the output for that. Same as input, flowers searching. In addition to the search output, it has this report of the privacy policy saying that, look, there is 3 matching happening on the 4 for the policy for this particular website. And why it is 3? Again, if you click on the report, it shows it's the same policy, so it's actually showing you the opt out again. Okay, so that's about some technologies that are available to actually make privacy decisions better, to provide enhancing experience for the user with respect to privacy. Okay, let's continue. Let's continue looking at social media, go back to social media. But again, all of this is very connected. So let's look at, we saw the recent privacy policy, right? We saw Facebook's recent privacy policy in week 2. We went through in details about what the policies are, all that. Now let's look at how information flow in Facebook has changed over a period of time, right? Over a period of time. Unfortunately, this data is only till 2009 or 2010. But I'm sure one can actually draw these kind of figures beyond that also to know what's going on. Lots of information is provided in this one graph. Let me help you understand what is there. In 2005, so this graph is for 2005. The way to read it is there's a set of time here. And there are different fields across here, which is name, make it a little bigger, name, likes, photos, wall posts, networks, contact information, friends, birthday, other profile data, gender, and picture. Picture is a profile picture, right? What does this mean? This is availability of personal data on Facebook, which is default settings. How to read this? This means that my profile picture that is there in 2005 was available to me, was available to my friends, was available to my network, all Facebook users. That's how you should read it. Friends was available to me, was available to friends, and it was also available to the network. Right? So that gives you a sense of, meaning you can go through each one of the information that is mentioned here. Gender was available to everybody. Right? Until here, it's available to all Facebook users. They could come to my profile and they could know my gender in 2005. Right? Hopefully that is helping. Take a pause, stop the video, look at the graph if you want more closely. Now, if you go to the next year, 2006, right? slight changes happen. If you look at changes, right? If you look at some of these changes that are happening in 2006, little bit of changes are happening in terms of friends, right? In terms of photos, not much change. All of them, name, picture, and gender is available to everybody, right? And friends, very similar. Let's jump to 2007. All right, just look at it in 2007 how things are changing. If just keep a watch on this part. All right. So what does this mean? This means that birth date, which was available only to me, if birth date is here, which is available to me and my friends. Now birth date is available to me, my friends, and all Facebook users also. Right, same thing with other profile data also. If you look at it, other profile data here, it was available to me and my friends only, but it increases me, my friends, and to all Facebook users, to the network, to the network. Let's keep the discussion also focused on these things. The categories are friends, you, friends, network, which is friends of friends, and all Facebook users. Okay, so that would give you a sense of in 2005 the information started flowing more, right? And now in 2009 the information is flowing much more. If you just look at the profile picture, just see this part, right? So this part is changed, which is your gender, picture, and name. From all Facebook users, it went to entire internet, which is anybody on the internet can actually look for your gender when they come to your Facebook profile. Right. Similarly, if you see friends, this part also moved from you, friends of friends, to all Facebook users. Any Facebook user could show up on your profile and see all your friends. That's 2009. I'll let you to go through these even more carefully. If you want, pause and watch the pictures more closely to see any other differences. But these are the differences that are very evident. 2009 December, the earlier one was 2009 November. Things are changing. Things are becoming more and more. So the basic idea. Let's jump to even 2010, right? So the idea here with this graph, I put the URL from where I took this images also here. If you look at the theme, what is the idea that's happening between from 2005 till 2010? Information is just flowing to larger set of people, right? Just look at it here. Only some set of is white. That's 2010 compared to 2005, right? Lot more things are whiter here. Right. So given that information flow, and I'm sure you'll also agree that 2010 is fine, but now I'm pretty sure the graph, if you draw it for 2020, it may be very different. I'll let you think about it. Think about how will the graph look if you draw it for 2021 right now. For these privacy preferences of Facebook default settings. Just check your own Facebook and think of some ways you think you can draw this graph and send it. It'll be an interesting exercise. And keep in mind all the changes that has happened between 2010 and 2020, where the privacy discussion itself has must have influenced Facebook privacy settings also. Okay. So that was knowing about Facebook privacy changes, how information has been flowing for many years between 2005 and 2010.